what is the hash table? Hash table is one of the type of data structure, and it stores the data in the form of array, and it stores the key and the value. Okay, and whenever we are storing data inside the array, and each value has their their unique address, unique index. Okay, and whenever we are storing in the hash table, and we are storing like the same, but there is some difference, and we are storing the and inside, for example, the inside the array, and each array we have a nested array, and inside we are storing two, which is the two item, which is the first item, which is the key, and the second item, which is the value. Okay, and for storing this, and for and the hash table is whenever it's very efficient whenever we are implementing for a search engine. Yes, because we are just giving the for key, and based on the key we can find very fast, very fast as how we are accessing the using the index, for finding the any value from the inside the array. We can just give the index, we can access super fast. Yes, which is the time complexity O1, and we can access as like so as the same how we are accessing the array, how we can access in the hash table also, but using the key. Okay, and for storing this, and we have a hash function, and it takes the key and it returns the number, and using this number we're going to store inside our array. Okay, and this is the same. Here is the thing. Okay, for example, imagine I have a array. Yes, for example, and this is my array, and this is my array. Yes, and whenever we are using the hash function, and if it gives the, for example, one of the here the address maybe which is the 1 2 3. Yes, 3. Yes, whenever you give the key to our hash function. Yes, and that hash function returns the 3. Okay, and then using this key we are storing here, which is the key and also value. Okay, and like so, and we are storing here, and after that whenever we get different key, and it gives me the hash function gives us, for example, maybe 1 or maybe 4, and we are just storing here. Okay, and we are just storing here, and like so, whenever we are using the hash function. Yes, the hash functions, and it takes the key. Yes, and this key can be the whenever this is inside the logic, and it returns in this kind, for example, the 3. Yes, and 3, and we give the different key, but hash function returns that the same again 1 3. Yes, in this case, and we cannot store here because we already stored at another value, which is another data here, and it means the 3, and we have another data here we must store that, but what we stored already, which is the collision, and we are meeting with collision. For handling the collision we have many ways, and first way for direct chaining, and also we have an open addressing, which is the linear probing. Yes, and let's we're going to see what is the direct chaining first. And whenever we are storing here, whenever we meet that the collision, yes, and we are storing here, and like chaining, like linked list, or maybe we can store here a nested list. Okay, and like so, and first data and the next data, and using the linked list we can store. Yes, we know linked list, and also we can store a nested list also. Okay, and this is the direct chaining is how it is very simple. And also we have a next way, which is the open addressing, which is we have a linear probing, and this is linear probing. It works, and whenever we are storing, for example, it returns 3. Yes, I cannot store here, and after that I'm linearly searching what is the empty space, which is here, and after that I'm just storing here. Okay, and maybe another I gave the key and it returns in the same 3, and I just linearly search and I'm storing here, and like so. Okay, and this is linear probing. And time complexity of our hash table, and firstly it depends on the collisions. It means whenever we have a less collision, for searching some value from inside our hash table, which is the O1, which is the time complexity is the constant, and the space complexity, the all space complexity is the constant. Okay, and for if we have a more collision, it means we are searching some value from inside our hash table, and it means we know the linked list or the list, and for searching any given value it takes the ON. Yes, time complexity ON, and the space complexity, which is the we're not gonna use more extra memory, and the space complexity will be constant. And whenever we have more collision, it means the time complexity will be the ON, which is the linear. Okay, and this is all about the hash table. And and a hash table in programming language we have in Python we have a dictionary, and also in the Java we have a hash map, and also in the in JavaScript we have a an object, yes. Okay, let's jump into VS Code. Let's want to create our hash table and using the Python list. And we're going to define the empty list, and inside we are nested. And then whenever we're handling the collision, we're going to use the direct chaining, and also we are just storing not a linked list. Instead, we're going to store the Python list. Implementation very easy. If you want, you can use a linked list like so. Okay, and for direct chaining, let's want to do it. Okay, let's going to create our hash table. And first we're going to create our class for our hash table, and inside I'm going to define the init function, which is there for initializing our hash table based on the Python list. Okay, let's going to do that. And also inside the class, we are going to create multiple functions to our hash table. And first I'm going to create a class, and which is the hash table. And inside first I'm initializing using the underscore init, which is the self. And inside, and firstly I'm write the self dot, which is the max. And this max, I'm just for what is the my array, what is the my list size. Okay, I'm just giving the 100 maybe. Okay, and whatever you want you can give here. Okay, maybe 10, maybe 100, but I'm going to give the 100. And after that I'm going to give the self dot, which is the here I'm going to write my arrays, which is the list. Okay, which is the array. It will be short term, and equal to here I'm going to write the list comprehension. And here I'm also inside I'm defining the empty list here, and after that I'm write the comprehensions, which is the for and the for I in, and which is the range function. We're going to create here, here we're going to create the empty list, which is the size 100. Okay, and here I'm going to write the self dot max, which is this. Okay, and for here I created, which is the 100, which is the list with the hundreds empty elements. Okay, and after that I just initialize it, and after that I'm going to create which is the get hash function, hashing function. Okay, and first I'm going to define the function, which is the get hash, and here it takes which is the self parameter and also key. Okay, which is this, it takes the key, and it returns the numbers, which is the index of where we are putting our value. Okay, and firstly I'm going to create the variable, which is the hash, and is equal to 0. And after that I'm going to iterate using the for and characters, which is the, and in which is here I'm just iterating my key. Okay, and for example the keys always will be the for example it can be the string, yes, and anything. I'm just iterating it, and then I'm just adding, and which is the here I'm going to write the ort, which is the assembly axial language. Axial language, which means and here we have characters, all characters, and we are just taking each of them, we are just converting to the numbers. For example, here maybe the AB, yes, I have 2 letters A, B, and I'm just iterating first A. For example, here it will be A maybe, and after that will be the next iteration. Whenever the next iteration, it will be the P, B, yes, and then I'm just taking to the hash. Okay, and for doing, I'm just write here characters, which is a charc. And after that, I'm just write which is the return, and outside the loop, the return, which is here I'm going to define it, which is I'm going to write the hash, which is the models like this, and the self dot max, and like, and the get hash and returns to the index of where we are putting here. Okay, and from the base on the key. Okay, and after that I'm going to create the next functions, which is the set, which is the get item for and the taking the item from our hash table. Okay, and firstly I'm going to write which is the get items. I'm going to define the functions, and the def and underscore the get item. This is the standard Python operators, get item. Whenever we are using the underscore get item and underscore, it means we are not accessing, whenever we are creating the instance of our hash table, we are not create, and for example I'm going to write the hash table, yes, and with a small case, and whenever I'm creating the instance of hash table, I'm not using dot, which is for example the hash dot. I'm not using hash dot. Instead I'm using what I'm using in the dictionary in Python. I'm just using it as like that. Okay, and first before I'm just writing the underscore get item and underscore, and here I'm going to write which is the get functions for getting all and the value from inside our hash tables. And firstly inside the parentheses I'm going to write the self, and which is also the key. Okay,
and inside I'm just defining the variable h is equal to, which is the self dot, I'm calling the here and get hash. Okay, here I'm just calling the get hash. Inside I'm going to give the key, and it returns us the index of that value. Okay, and after that I'm going to iterate and using the for, and here I'm iterating, and the self dot, which is this one. Okay, what is this? And for doing, I'm going to write the item in self dot r, and here I'm just write the h. Okay, which is this, whenever index of our the value. Okay, and inside I'm just check the if and the item and 0 if this is equal to key, if like so, and I'm just return, and here I'm just return item, which is the first, which is the value. I'm just returning here the value. Okay, whenever we are calling this, we just give the inside the curly bracket, yes, we give the key, and then it returns and the value of what is that exactly, what is the value of this. Okay, and we're going to create our next functions, which is the set item for adding to our hash table. And for doing, I'm going to define a function, which is the def __ set item, and this is also a Python standard operator. Okay, and I'm going to write the self here, and also key and value also, and like so. Okay, and inside, and firstly we are always taking what is the key and what is the number of and our value. Okay, and firstly we are generating our using the hash functions. Okay, we're going to call and get hash, and I'm going to give the key here and the key, and it returns the numbers, integer numbers. Okay, and then I'm using that numbers, I'm just storing into my hash table. Okay, and also maybe and whenever we are storing the value in our hash table, I need to check what is the, for example, maybe there is the whenever it returns the, for example, and some cases where we give the key and it returns the for example 9, and whenever we give a different key but it returns the same number. Okay, and which is the here the collision. Okay, and we are here and we are going to handle the collision. Okay, and I'm going to write the logic that is for handling the collision, and we are storing, which is the nested, for example, and whenever we spoke about the handling collision, yes, and we are just storing as a linked list or maybe the list inside the nested list. Okay, and for doing, and firstly I'm going to define, which is the found variable, and this found variable we just give the false, which is the default false, and whenever we are iterating, whenever this key is inside, we are maybe inside we have some, and the same, for example, maybe we have whenever in our hash table we meet the collision, yes, we are just handle, and for doing this I'm going to iterate for, yes, and here I'm going to write, firstly we are just taking the two variable, which is the index and also item, and in here I'm going to use the enumerate functions, and here the enumerate functions, and we can access the, which is the two variables. Okay, and inside I'm going to write the self dot r, and I'm going to give the h here. Okay, and inside firstly I'm going to check and if length of our item if equal to 2, it means whenever length of item is equal to 2, it means we have a and the value inside. Okay, and we have data. We know every time we are storing the key and value, it means 2 data, and the length must be the 2. Okay, and whenever item length is equal to 2, it means we have a data, and also I'm going to check the item and the first, which is this, which is the key. If this is equal to key, yes, and it means, and that, for example, I'm giving the, for example, the room, yes, the room is, for example, maybe 2. When I'm storing room, the key room, and the value is 2, and maybe, and after some times I'm going to give the, after some line of code, I'm going to give the again the room and a different variable, maybe the 10, and for this kind of cases I'm just overwrite. Okay, and because we cannot store the same exactly key, we cannot store like this. Okay, instead we are just overwrite. Okay, and sometimes the key is different, but they will be stored in the same index inside. For example, this is the whenever it will happen, and we are just append inside the nested list. Okay, and here I'm going to write firstly and a self dot rr, and here I'm just write h, and after that I'm going to write the index, and this one is equal to, which is the here I'm going to create the list, yes, empty list, and I'm going to give the key and value, which is the, I'm just updating this, okay, and after that I'm just update the, which is the found, which is the found is equal to true, because we have that value over, okay, and after that I'm going to break the loop, and outside the loop I'm just write the one more if condition. Whenever this code it will not work, for example, this is maybe we are adding another and the key is not equal, yes, for example, this condition will not work. Whenever like this, I'm going to write here one more if condition, which is the if not found, okay, and if not found, and this is whenever we are searching this, yes, here, whenever we are comparing this, if not, I'm going to write them, just append self dot r here, and I'm going to give h, and after that I'm just write the append functions, append, and inside empty in the list, and which is the key and value, and like so, okay, and this is our set item functions. Let's save it. Okay, we're going to check our hash table. Firstly, I'm going to create the instance of hash table, and the hash table is equal to hash table, which is this, and then I'm just write the hash table, and in the square bracket I'm going to give the key here, for example room, maybe room, yes, and this is equal to maybe and 10, okay, and after that I'm going to create some more, and a 6, and this is equal to 13, and maybe a 20, and maybe 17, and like so, okay, and after that I'm going to just call, which is the hash and dot r, and it's going to print it, save it, open the terminal, and write the Python and the hash.py, and here you can see we have 100 elements inside the list, and here I wrote all my, which is this, as you see, and you can change maybe some little, maybe 10, and it's okay, and let's save it and open it, and you can see this is the clearly, and whenever you see this is the, we have one collision here, okay, and which is that whenever we are giving this element, which is this key, yes, and our hash functions, which is the get hash, it returns the same number. Whenever we give the room 6, it returns the same number whenever we give this key, okay, and therefore this is whenever we handle the, which is the collision here, okay. Let's want to check our get functions, which is the get item hash table, and inside a square bracket, and just I'm going to write the room, and let's open terminal, and this, let's check it, get item, okay, I'm just print it, I'm going to write the print and save it, and you can see this is the 10, which is this room, and whenever we give the maybe the 6, yes, and it returns me the 13, and here whenever I give the 17, it returns me the, which is the 20, and let's want to create our last function, which is the delete item, and first we're going to define a def underscore del item underscore, and this is also, I know this is also standard operator for Python, and underscore del item. Inside I'm going to write a self and also a key, and inside the functions, firstly we're going to get the hash key, which is the hash numbers, h is equal to, and self dot get hash, and we're going to give the key here, and after that I'm going to iterate using the for loop, and here I'm just taking the index and also item in enumerate, which is this, I'm going to give the self dot the r, and I'm going to give this h, and inside firstly we're going to check, which is the if item, and which is the first index is equal to key, if like so, we're going to delete that one, which is the del, and the self dot r, and here the h, and after that I'm going to write the index, which is, and like so, okay, and let's save it, and also we're going to check, and first I'm going to hash table, I'm going to write in here, and maybe we're going to delete that one, which is the 10, okay, I'm going to write here in the room, and let's want to delete that one. Del. And save it and open a terminal. If let's we're gonna print entire our hash table, and using array.r. okay, and let's save it. And you can see there is we deleted that value. Okay, this is the 10. And let's want to comment this, and you can see is that one. And you can see here this is a room 10, which is that one located here. Whenever we uncomment this, and we are deleting that value, okay, and like so, okay, and you can clearly see. And also we can delete maybe the 6th one also, okay, and that one, okay, like so.